we have a problem. We have an input is a string s and a string t, and then output is an integer that show the minimum editing distance from string s to string t. So the minimal operation to convert to change the string s into the string t, and they allow like three operation. Three operations allow. One is insertion, deletion, and override. Okay, for this problem, right? As a string problem, we usually use two pointers to travel to the string. So we indicate as a pointer I to S and pointer J to T, and then we will work through some example. Okay, so example. Let's say you have a string S is equal to A, B, C, and T is equal to A, B, and D. Okay, so in order to convert a string S into T, right? We have a pointer I and pointer J right here. We travel through it. I and J, the first character A and A is equal. Skip it. I plus 1, J plus 1, B, we skip it because it's equal. I plus 2, and J is plus 2, C and D is different. So between the three operation, insertion costs the most, so we skip it. Deletion is also costs the most, but after we delete, we add it back again. So override is the cheapest operation, so we're gonna do override, and then it will cost one operation, so it will return 1. So as we call, right, we're gonna create a recursive function. So as right here, I create a recursive function with the base case is either of the string are empty, and then if the string equal to each other, just the length of one of the string. And this is in general case right here. So if the first character is equal, we skip it, and then we shorten the string from 1 to the end. Same thing with override. So when we do override, right, we add 1. So 1 is like one cow operation that we do override, and then we keep doing recursive for this one. So for override, right, the rest of the string have to be equal. For deletion, we move I, but we keep J. For insertion, we keep I, but we move J. Yeah, and then return, we find the minimal of those three operation. But for this solution, right, it's kind of expensive in terms of time complexity. So let me calculate the time complexity of this one. So we do the count. So this is 1, 2. So this is 2. Yeah, count. So this is 2. This is also 2. This is also 2. 6 total. So this one is 1 t minus 1. One t minus 1. See t and minus 1. Same below here. T and minus 1. T minus 1. And minimal is 3. Okay, so let's calculate time complexity. 2, 2, 2, 2. So 2 plus 2 plus 2 plus 1 plus t minus 1. T and 2 minus 1, 2 minus 1. 3 times like that. 3 times like that. And then plus 3. So t and would be equal to 7, 10. So 3 times t minus 1 plus 10. And then we substitute n plus 1. So we have 3 times and then we keep recursively like that. So we have the general case is t equal to 3 over 3 over k. Yeah, 3 over n. T n t n minus k plus c some function, and then this is greater than 3 over n. No, and this is equal to O 3 over n, and or we can say it is O 2 over n. So the time complexity of this one time complexity is O 2 to the power n. So it's super slow. Super slow. Yeah, so that's why we're gonna convert this function into dynamic programming. So in order to do that, right, first one is we're gonna create an array. Array A. Initialize everything in 0 to 0. J in range length s plus 1, 2 plus 1 for j, for I in range length t. This is t s. And then for base case, right? We just initialize the corner of the array. Then this base case, is count to the general case, so we can delete everything. So this is deletion, this is insertion, and this is override. And then we just return it a length t. Yeah, and that's it. That's how we convert this one to dynamic programming. Okay, let's do some tests. I had that test right there. Let me do another one. Alright, we have my hand. This one right here. Yeah. Okay, looking good. Let's do some tests on it. 10, 28. Yeah, that's it. Alright. Thank you for listening, guys.